In this video I'm going to go over the concept of quantum computing, and I'll just give you a taste of it. If you're interested in the topic, you can learn more about it online. Um, the quantum computing basically is applying the laws of quantum physics, quantum mechanics, to data processing. So data processing is basically computing, processing information and so on, and the only difference between that and classical computing is applying the laws of quantum mechanics. So whereas in classical computers we have streams of bits like 1, 0, 0, 1 that encode information, in this case what we have are qubits, which also do the same thing. But what they have special is basically their demonstration of certain qualities like superposition and entanglement. These are two quantum mechanics concepts. Superposition basically means that a quantum particle or a system could be in multiple states at the same time. So it could be up, down, and even these two together simultaneously. Entanglement means quantum particles, and quantum systems can be inextricably linked. So one particle might be upwards and the other might also be upwards, and no matter how much of a distance separates them, they will always be correlated and linked. Some of their properties will be linked, and no matter how far away you take them. And so this is something that is exploited. These two properties are exploited, and we come up with powerful processing. So this is one of the most attractive qualities of quantum computing, is that it allows us to process data so much faster than classical computers. And one of the applications that we're looking and excited about is factoring large numbers. Cryptography as we know it, classical cryptography as we know it today, basically like securing your credit card transactions and so on, relies on factoring, on the fact that classical computers really can't factor really large numbers. Like we're talking about 500-digit numbers. They really can't factor a really large number. So this is because it would take them really, really long time, and so we're just saying that really it would be impractical for anyone to break the code this way. Well, with quantum computers, this will no longer be the case. If we have really powerful processors, quantum computers, then we could basically just, cryptography as we know it today will be destroyed and won't work anymore. And so this is one of the things. But at the same time, it offers us an alternative, and we could use, for example, the property of entanglement in cryptography, and use the fact that two particles or two quantum systems will always be linked, no matter what separation exists between them. So they might have a property that is very much similar, and this could be used in a certain communication that we want to keep secret. And the cool thing about it is that whenever there's anyone who eavesdrops on the communication and tries to secretly observe the system, then what happens, and this is also part of quantum mechanics, what happens is that it disturbs the balance of the system, and automatically both parties could actually detect that there was someone that was eavesdropping on their system. So this is one of the neat things about entanglement, that not only are they correlated, but the moment that someone actually peeks in and looks at your code or looks at whatever you're trying to transmit, then the system breaks down, and therefore they won't be able to crack your system. And so this is another alternative way for cryptography. So this is just scratching the surface of quantum computing. You could learn a lot more online.